Okay, Assalamualaikum and good day. Today we are going to learn about chapter 6, the analysis of variance ANOVA. So now let's compare the difference between chapter 4 and chapter 6. So previously chapter 4, we have learned about two population means. Okay, however for chapter 6, we are going to learn more than two population means. So let's look at the problems that we have here. So the problems is the same. We want to determine whether the brand of laundry detergent used affects the amount of dirt removed. So what's the difference between 4 and 6 chapters? So for chapter 4, we only compare two different brands, which is brand A and brand B. While for chapter 6, now we have more than two, which is 4 brands. Okay, brand A, B, C, and D. So now, the factor that we have here, the detergents are called as the factor. So we only have one factor, which is detergent. So for chapter 6 also, our factor is detergents. However, for levels, since we have two brands, so that means now our levels would be 2. So the levels is denoted by K. While for chapter 6, we have K is equal to 4 because our brands, we have 4 brands. Now let's look at the hypothesis testing. So now the hypothesis testing for the two populations is like this for chapter 4. So if you still remember the populations, the hypothesis testing for the two population means in chapter 4 is like this. Okay. So we have two population. While for chapter 6, instead of 2, now we have more than 2 population, which is until K. So now, for example, since you have 4 levels, so that means, okay, your mu would be until 4. Okay, while your H1 is 4, okay, will stay the same, which is mu1 is not equal to mu j. So this means that for at least one of the mean is not the same with the another mean. So that's why instead of we put mu1 is not equal to mu3, we do mu I is not equal to mu j. In this chapter, we are not determining which one is not the same with the other one. So that's why we put I and j here. Okay, so similar to the hypothesis testing in chapter 4, for chapter 6, we also need to make a decision whether to accept or to reject the hypothesis. So to make that decision, we use the one-way ANOVA. Okay, now let's look at the examples. So the question is, perform the analysis of variance. So the analysis of variance is called as ANOVA. Okay, and test the hypothesis at 0.05 level of significance. That means this one is for alpha. That the mean, okay, the mean, yeah class, that means they want you to test for the mu. The mean amount of dirt removed by the different detergent are the same for all 4 brands. Okay, discuss the results. So to answer these questions, there are several steps that we need to perform to answer that. Okay, first, we need to determine the value of N and K. So these both, this N and K, we can obtain from the table. Second, make a hypothesis statement. Okay, don't forget to check how many levels that you have. So the levels here is denoted by K, remember. Find the F calculated. So we use the ANOVA table. Find the critical value F, okay, which is this one. Okay, decision rule, accept or reject. So we will reject if the F calculated is more than the critical value F, and then make the conclusion. Okay, now let's see how to determine the value of n and k. So n is defined as the number of observation. So the number of observation is how many data, how many numbers that you have here in the table. So you need to calculate it one by one. So we have 1, okay, 1 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for every column we have 10 numbers. So that means 10, 20, 30 and 40. That means we have 40 observation. Okay, and how many levels here that we have? So remember the levels or the K means how many brands that we have in this question. So now we have A, B, C and D. So that means we have 4K. So after we determine the value of N and K, then we make a hypothesis statement. So the hypothesis statement, remember since we have 4 levels, so that means your mu is until 4 only. And your alternative would be the same. Your mu I is not equal to mu j for at least one ij. So you need to rewrite this statement. It would be the same for everything in every example in this chapter. And then after you make hypothesis statement, then we want to find the value of your f. Okay. So for this chapter, we are going to reject or accept by comparing the value of your f test and f critical value. We are not using the z test. Okay. So how to find the value of f calculated? So we use this ANOVA table. So this is called as the ANOVA table. Okay, so how to find this f calculated? So the f calculated is here. Okay, so to find the value of f calculated, so this is the formula MSTRT, you should divide it by MSE. This one, MSTRT, you should divide it by MSE. So how to find the value of MSTRT and MSE? Okay, so to find the value of MSTRT and MSE, you need to use this formula. So how to derive these formulas, how to obtain these formulas? Okay, so these formulas, it is shown in your textbook, but you don't have to derive it. You just directly use these formulas. Okay, and this is the models. Okay, the models that we obtain from the data. So the Yij is your data, and the mu I, epsilon, mu and alpha is the parameters of your data. Okay, so these parameters will will visualize your pattern of the data. Okay, and this epsilon, this is also called as the error. It should be normal. Okay, and the restriction, the combination of alpha is equal to 0. Okay, so this one is just the model and the assumptions of the models. Okay, however, okay, you don't have to use this to find the value of f calculated. Okay, you just use the SST until MSE to find the value of the f calculated. Okay, now let's find the value of your f calculated using the ANOVA table. Okay, so from this formula, how to find the value? So let's look at SST first. So from the SST, we have here the small yij. So the small y means, okay, it means the data inside the table. So you see here, okay, Yij, that means Yi, I is the value of your level. Okay, I is for level, and N is for the observation for every brand. Okay, so you see here, if your level is 1, so that means your level is A, for example, and the number observation in A is 1. Okay, so that means, okay, This one is 1, 2, 3, 4. This is for your K. Okay, so that means y11 is equal to 11. How about y12? So the first one is for level, right? So your level 1 is K, this one. So that means level 1, and your J is 2. Your number observation, J is equal to 2. So that means this is 2. So this is n is equal to 1, n is equal to 2, n is equal to 3 until n is equal to 10. Okay, so that means your y12 is equal to 13 until y110, the value is 14. How about when your y21? So that means now your level is 2 and your number of observation is 1. So that means this is 12. How about y210? Okay, so the value would be, this one would be 18. Okay, so now that means the yij squared means you have to sub in all the values inside the tables into the formula. So that means 11 squared plus 13 squared plus 17 squared until here, until the 18 squared. Every numbers inside the table you have to square and sum total all of the data that has been squared. And then minus this y dot dot means y big y dot dot means, okay, big y dot dot means the total value of all this number. Okay, so this number is the total value for every brand. So your y big y dot dot means the total value for every total of each brand. So that means 139 plus 172 plus 183 plus 149, you will get 643. That is for your y big dot dot. And your capital N is equal to, remember your capital N is equal to 40. So you divide it by 40. Okay, so this would be the value for your SST. Okay, let me erase first some of the numbers here. Okay. Okay, now, how about the value of your SS treatment, SSTRT? Okay, so to find the value of this SS treatment, SSTRT, so you have to do, what you have to do is that you need to use this formula. So what does this mean? Big YI. So big YI means the total value of every level. So I is for level, since I is from 1 until K. So that means I is for level. So that means when your Y, so that means this 139 is for your Y1. 172 is for your Y2. This one is for your Y3. And this one is for your Y4. Okay, so you sub in all this y1 until y4 into the formula. Don't forget to square all of the values and divide it by the small ny. Okay, so what's the difference between ni? What's the difference between ni and n? So n is the number of every level, the small n, while the big N is the total number for every levels. So that means your n1 would be how many numbers of how many numbers that you have here? 1, 2 until 10, right? So your n, small n for level 1 is 10. Level 2 is also 10. Level 3 is also 10. And your level 4 is also 10. So your n would be n1 plus n2 plus n3 plus n4. So your big N would be 40. Okay, so that's the difference between small n and big N. And then remember y dot dot means the total value of y1, y2, y3 and y4. So this one is 643 squared divided by big N. Your big N is 40. So you will get this answer. How about the SSE? So for SSE, so the value of SST minus SSTRT. So now your SST is 336.775. 336.775 and your SSTRT is 123.275. Okay, so just sub in into the formulas and you will get this answer. Okay, so now let me change the color first. So now you already found the value of SSTRT, okay? SST, SSE and SSTRT. So you already found the values. So just sub in the values into the table. Okay, for example, SSTRT, the value is 123.275. SSE, the value is 213.5. And wait a class, let me erase this one first. Okay, and then the value of your SST is equal to 336.775. Okay, so how about your K minus 1? Now the value of your K is 4. So 4 minus 1 is 3. Now your N minus K is 40 minus 4 is 36. Okay, capital N minus 1 is 40 minus 1, so it would be 39. How about your MS treatment and MSE? So your MS treatment is equal to SS treatment divided by K minus 1. So now your SS treatment is 123.275 divided by K minus 1 is 3. Okay, so you will get your MS treatment. Okay, or if you forgot the formulas, okay, you can also do like this. For MSTRT, so you just take, okay, the one with the same row, the first column divided by the second column. For the MSE as well, the first column with the same row as the MSE divided by N minus K. Okay, so this one your SSE is 213.5 divided by your N minus K is 36. Okay, then you will get the value of your MSTRT and MSE. Okay, so now this is the value of your, okay, MSTRT. So this is the value of your MSTRT. So remember, 123 divided by 3 and this one 213.5 divided by 36, you will get this 5.9306. So now, after we already found all these values inside the table, find the F calculated. Okay, so remember the formula of the F calculated is, okay, the first row divided by the second row. MS treatment divided by MSE. So that means here 41.0917 divided by 5.9306. So you will get 6.93. Okay. So now you already find the value of your F calculated, which is 6.93 from here. 6.93. Okay. So after you already found the value of your F, which is 6.93, find the value of your critical value. So now the critical value, your alpha is 0.05. Your K minus 1 is 4 minus 1. Okay, which is also from the ANOVA table is 3. Okay, this is K minus 1, remember, and this is N minus K. Okay, or if you don't remember this one, you could also write 40 minus 4. So you will get 3 and 36. Okay, so from your F table, okay, the value that you will get here for your F critical value is 2.87. So after you obtain the critical value, so now you decide whether to accept or to reject. Okay, so now you need to check. Remember, for the F distribution is like this. The 0 is at the very left corner. Okay, and your F critical is about 2.87. So maybe, for example, around here, 2.87. So now your computed F is 6.93. So remember, this one, okay, the rejected region is to the right side. Now we want to check whether we should reject or accept the hypothesis. So now your calculated of your F is 6.93, right? 6.93 is after 2.87, which is around here. Okay, 6.93. Okay, so since 6.93 is inside the rejected region, or since the 6.93 is larger than 2.87, that means we reject H null. Okay. So after you make a decision, don't forget to make the conclusion. Okay, since we reject the H null, that means, okay, we accept the alternative hypothesis, which means, okay, at least one of the mu is not the same. So this, okay, so don't forget to make conclusion. This means that at least one of the mean is not the same. So the different brand of laundry detergent has an effect on the mean amount of dirt removed from the laundry. Okay, so don't forget to make the conclusion.